Bismillahirrahmanirrahim, dear students. Today we are going to discuss lecture number 45, grade 12, substitution reactions, chapter number 16, lecture number 45. So, in the previous lecture, I told you the substitution of halogen, how the halogen electrophile is substitute hydrogen, and I wrote the chemical reaction in the previous lecture. Now, the students, if you are going to write the mechanism for this chemical reaction, I will tell you just like substitution reactions, and these are the electrophilic substitution reactions. Electrophilic substitution reactions of benzene. So suppose this is the electrophile, which is a powerful. This is a condition that benzene is a highly stable, and due to the delocalized electrons, so weak electrophile cannot attack the benzene ring. Due to this reason, this electrophile is going to be attached to the benzene ring. So this is the electrophile. These are the pi electrons. These are the pi electrons going to attack here. Lecture number 45, 16, chapter 2nd year. So this is going to be attack electrophile here in the presence of catalyst. Okay. Then what happens? This electrophile and this hydrogen. Now hydrogen is exposed because this electrophile is going to replace the another electrophile, which is hydrogen. So valency of this carbon is satisfied 1, 2, 3 and 4, but the valency of this carbon is not satisfied. So that's why positive charge is created here. In the next step, this hydrogen is substituted by the electrophile. So you will get a substituted benzene now. The bond is re-established. So dear student, this is the mechanism of the electrophilic substitution reaction of benzene. Already I told you in the previous lecture how the halogens are going to be substituted. Then there are many chemical reactions. Now nitration. But first of all, you have to generate or prepare a strong or powerful electrophile. Nitration of benzene. So this will be a electrophile. This nitro group will be a electrophile, and this nitro group is going to be formed when the nitric acid and sulfuric acid are going to be react with each other. So this is the nitric acid. And this is the sulfuric acid. Heat. So dear students, the hydroxyl group is removed from here, and the hydrogen is removed from the sulfuric acid. So we will form the powerful electrophile. This is a powerful electrophile, nitro group, and then nucleophile, base, hydrogen sulfate, and plus water. You must write this equation. Now, as in the previous mechanism, this is I told the electrophile E is the same. You have to use. So this is a benzene. There is a double bond, electrophile. I told you these pi electrons are acting as a nucleophile. So these are the nucleophile always attack the electrophile. Then base. This is the base. So you will get an intermediate transition state or intermediate state. Here the nitro group is going to be attached to this carbon atom, and I told you the valency of this carbon is not satisfied, so positive charge is created. Then in the next step, this hydrogen proton is substituted by the nitro group. So you will get a product. The pi bond is regenerated. This compound is called nitrobenzene. This is the nitrobenzene, and this hydrogen ion and base to form again sulfuric acid. So dear student, this is the mechanism of nitration of benzene. So if we write the same chemical reaction in one step chemical reaction, you can write this one. And this is the mechanism. Path of the chemical reaction is given here. How the chemical reaction proceed. So this is the benzene, nitric acid, sulfuric acid, heat, you will get nitrobenzene plus water. So this is the one-step reaction for the nitration of benzene, and these steps are the showing the mechanism for the chemical reaction. So there is a nitro. This is the nitro group which is going to be used as a powerful electrophile for the nitration of benzene. Then there is another very important chemical reaction, sulfonation. The introduction of sulfonic group, sulfonating group, sulfonic group. From the sulfuric acid in benzene is substituting hydrogen from the benzene ring is called sulfonation. When the benzene is heated with the fuming sulfuric acid, concentrated sulfuric acid yields benzene sulfonic acid. Fuming sulfuric acid is free sulfur trioxide which is electron deficient. Fuming sulfuric acid has free sulfur trioxide. Free sulfur trioxide present with the sulfuric acid is called fuming sulfuric acid. So this sulfur trioxide which is going to be attached with the benzene. So first I am going to write the one-step reaction, then I will explain the mechanism. Sulfonation of benzene. Student, sulfur trioxide when used as an electrophile I will explain how. So in one step reaction, if you want to write one step reaction, so benzene is going to be heated with the benzene, sulfuric acid, heat, benzene sulfuric acid. This is a benzene sulfuric acid. And water. So dear students, hydrogen and oxygen, OH is removed from here. One hydrogen is substituted from the sulfonate group to give a SO3H. This is a benzene sulfuric acid, or you can write this chemical reaction in one step in this form also. This is sulfur trioxide as electrophile in presence of fuming sulfuric acid in sulfur trioxide with sulfuric acid. So dear students, this sulfur trioxide SO3 is going to be attached with the benzene, and you know there is a hydrogen with the benzene is substituted to attach with the SO3 to make a SO3H. So again you will get a benzene sulfuric acid. So these two reactions are valid and also correct. This is only one step, then I will explain mechanism reaction, how this chemical reaction proceed. So again I am telling you introducing of sulfonic acid group SO3H. In benzene, substituting hydrogen from the benzene is called sulfonation. Benzene is heated with concentrated sulfuric acid, yields benzene sulfonic acid. Also we use fuming sulfuric acid, free sulfur trioxide present with the sulfuric acid is also called fuming sulfuric acid. So it is electron deficient, it is used as a electrophile, also give this yield this product. So both chemical reactions are correct. Now students, how I am going to explain the mechanism for this chemical reaction to make the benzene sulfuric acid mechanism. First of all, you have to generate the strong electrophile. So a strong electrophile is going to be generated by the addition of the two molecules of sulfuric acid. Then you will get this electrophile, hydrogen sulfate plus hydronium ion. So you will get this one. So we use this sulfonating group. This is the sulfonating group. We are not going to use this as a powerful electrophile. So powerful electrophile is going to be stable here. So same. going to write down this one. So this pi electrons being a nucleophile attack the electrophile which is electron deficient. So dear students, to form intermediate product, there is a positive charge created and hydrogen is here, and this is the SO like this one. Because the oxidation number of sulfur is 6, so one bond is here, 2 and 2, 4 and 5 and 6. The negative charge is created on the oxygen and positive charge is created on the carbon because our valency of carbon is not satisfied. Now what happened in the next? There will be a substitution of hydrogen. Because we are talking about the electrophilic substitution reaction. So this hydrogen is electrophile, so it is going to be substituted in the presence of base. This presence of base, so this hydrogen is going to be removed and this bond is re-established. And we get the sulfuric acid now. Then we have hydronium ion in the last acid, hydronium ion. So what happens? This hydronium ion is the nucleophile and the hydrogen is positive here, attached with the oxygen to form SO3H plus water. So this is your product, benzene sulfonic acid. So dear students, first we have to generate the strong electrophile. Sulfur trioxide is electron deficient. On the center of oxygen, sulfur, there are positive charge. So we have to generate here by using 2 molecules of sulfuric acid with the base, which is called the hydrogen sulfate, and with the hydronium ion, hydroxynium ion. Okay. After generation, this is the same. I have written in the bonding form. Pi electrons of the benzene, which are the nucleophile, attack the electrophile. You will get the intermediate product, the 2 charges, because of the hydrogen is also here. So you attack this sulfonated group. The valency of this carbon is not satisfied to take positive charge, and there is oxygen. Valency of this oxygen is not satisfied to take negative charge. In the next step, this base HSO4 negative is going to be attached here. So hydrogen is going to be substituted to make a sulfuric acid. Valency of the benzene is re-established complete, and the valency of oxygen is not satisfied still. And we have electrophile, which is a hydroxynium ion. From hydroxynium ion, this is a hydrogen shifted to here to make the benzene sulfuric acid, and the water is going to be removed. Dear students, this is called sulfonation. These reactions are very important, electrophilic substitution reactions. Halogenations, in the previous lecture I told you, so I am going to repeat this again with the bromine. So dear students, write down this. We are talking about the electrophilic substitution reactions of benzene. When one electrophile substitute, which should be a strong electrophile, halogenation of benzene, so we have to create the electrophile. So dear students, first of all you have to form a catalyst, iron, bromine, to give ferric bromide, which is a catalyst. This is a catalyst, ferric bromide. Then this ferric bromide going to be react with bromine, so you will get liquefied bromine plus complex iron tetra bromide. So this bromine is positive, is electrophile, which is a powerful, the same mechanism, same. Positive, liquefied, complex, intermediate product. Electrophile is going to be substituted hydrogen, positive charge create, valence not satisfied, and then in the next step, this proton substituted, you will get the bromobenzene. Bromobenzene. Then this hydrogen ion plus iron bromide complex to give the hydrogen bromide plus iron tribromide. Dear students, this is a mechanism already I told you in the previous lecture for the halogenation. First of all, you have to generate the electrophile, which should be powerful because due to the extensive delocalized electron present in the benzene, so benzene sheath cannot be disturbed. So only the powerful electrophile can break the sheath of the electronic cloud of the benzene, so make the substitution reactions possible. So this is the mechanism of the halogenation. Dear students, there is another one. When alkyl benzene, when there is a already substituted benzene, when there is a alkyl benzene, toluene is going to be reacted with chlorine. The conditions are different, dear students. This is the alkyl benzene. This is a toluene, and you are going to pass chlorine gas. Conditions are now different. In the presence of diffused sunlight, so there will be no effect on the sheet of benzene ring. If you use the sunlight, diffuse sunlight, ultraviolet light, then there will be no effect on the benzene ring. Only the hydrogen will be substituted from here. So, just like you done halogenation of chlorination of methane. So, dear students, one hydrogen is removed and one chlorine is added. You will get a HCl. So this is step number 1. Step number 2. Again, chlorine is added one more hydrogen is substituted. In the third step, so here the chemical reaction stopped. Now students, the naming. The first is called benzyl chloride. This is called benzyl chloride and this is called benzol. Chloride, and the last one is called benzoyl trichloride. So you will get a mixture of these products. When alkyl benzene are treated with chlorine or bromine in the presence of sunlight, only the alkyl groups are substituted. There is no influence on the electronic sheath of electronic cloud, electronic sheath pi electrons of benzene. In the presence of diffuse sunlight, there will be no influence on the benzene ring. So dear students, this is the substitution of alkyl group in the benzene. This topic is very important, which I am going to discuss again. This is the same one. Again, this is the same substitution reaction. But there is a special name. The special name of this, which is called Friedel-Crafts reaction. Friedel-Crafts reaction. Now, when you are introducing alkyl group, then this is called Friedel-Crafts alkylation. So maybe use methyl, maybe use ethyl or propyl water maybe. So when you are introducing alkyl group with the benzene ring, so this is called alkylation of benzene. So this general reaction is called Friedel-Crafts alkylation. The introducing of alkyl group and benzene ring in the presence of a catalyst because of during the electrophilic substitution we should form or generate the powerful electrophile. That is why we use the catalyst here, alkyl halide and aluminium halide, aluminum trichloride. If you use chlorine, then aluminum trichloride you should use as a catalyst. So this is called Friedel and Crafts alkylation. So if I am going to write a one-step reaction, you will get toluene. This is the one-step reaction. There is a alkyl group. Methyl is going to be attached here. Hydrogen is substituted to make HCl. Aluminum chloride is a catalyst. So dear students, if you are going to write the mechanism of this chemical reaction, then first we generate the powerful electrophile. So this powerful electrophile can be generated from the methyl chloride, and aluminum trichloride is a catalyst. So you will get the positive charge, which is a powerful electrophile, and then there is a complex aluminum tetrachloride complex like this one. So you must write this to generate the powerful electrophile first. So this powerful electrophile penetrate the electronic sheath, electronic cloud of the benzene. Electrons are going to be attached here in the presence of a base, which is called aluminum tetrachloride. So you will form the intermediate product. Hydrogen is going to be attached here already. Methyl represent balance in our satisfied positive charge is created. Now students, in the presence of base, so this hydrogen proton is substituted, this proton is substituted, removed from here, and you will get the product which is called a toluene, and the bond is regenerated. So this product is called toluene. Toluene is formed here, hydrogen ion already, we have a complex AlCl4 negative, so you will get HCl, and the catalyst is going to be removed back. This is the mechanism reaction for the alkylation of benzene is called Friedel-Crafts reaction, and we introduce alkyl, that's why we call Friedel-Crafts alkylation. If you are going to use the ethyl, then you will get ethyl benzene. If you use N-propyl chloride, you will call N-propyl benzene. If you introduce only methyl, you will get a methyl benzene or toluene. Toluene can be formed, ethyl benzene can be formed, N-propyl benzene can be formed, isopropyl benzene can be formed, which is called cumin. So dear students, this is a mechanism for this chemical reaction. So we are going to finish. There are more two chemical reactions for this, and then we have to go end of this chapter. Very important these topics are. So thank you very much.